Section 110.3 B. If the 1999 National Electrical Code states that electrical connections and splices shall be made only with approved devices or methods. Furthermore, Section 300.15 C states that conductors shall be connected or spliced to each other or to terminals or connectors in a manner that is mechanically secure and electrically continuous. Wire nuts are indeed approved devices for splicing conductors. The NEC does not specify the color of wire nuts that must be used for general applications. Therefore, the argument that only green wire nuts are acceptable is generally incorrect. According to the 1999 NEC, any color of wire nut that is approved for the application can be considered acceptable. However, there are exceptions to consider. There may be local amendments to the NEC implemented at the city, county, or state level that could potentially prohibit the use of certain colored wire nuts in specific applications. While it is highly unlikely that any such amendments would exist concerning the prohibition of red wire nuts for grounding conductors, it is essential to verify local regulations. To avoid disputes, it is often recommended to use green wire nuts specifically for splicing ground wires, as this is a widely recognized convention. However, if red wire nuts are the only ones readily available, using them does not necessarily constitute a violation of the NEC, provided they are approved for the application in terms of wire gauge and voltage rating. To ensure compliance and avoid potential issues with inspections, always consult the local electrical codes and regulations in your specific jurisdiction. If any doubts persist, contacting the local authority having jurisdiction, or ODGE, directly for clarification is advised. Always prioritize safety and adhere to the applicable electrical codes and standards to ensure a safe and compliant electrical installation. Selecting the appropriate wire nut size and type is crucial for a safe and reliable electrical connection. Wire nuts are color-coded to indicate the range of wire sizes they can accommodate. Using the correct size ensures a tight, secure connection that prevents loose wires, overheating, and potential electrical hazards. To choose the right wire nut, you need to know the gauge and number of wires you'll be connecting. Wire gauge refers to the thickness of the wire, and it's typically printed on the wire insulation. Common wire gauges in residential wiring include 14, 12, and 10 American wire gauge or AWG. Once you know the wire gauge and the number of wires, you can consult a wire nut sizing chart provided by the manufacturer. These charts indicate the appropriate wire nut color and part number for specific wire combinations. Generally, smaller wire nuts, like those colored blue or gray, are used for smaller gauge wires and fewer wire combinations. Larger wire nuts, such as those colored orange or yellow, are designed for larger gauge wires and more wire combinations. It's essential to follow the manufacturer's instructions for installing wire nuts. Firstly, strip the insulation from the ends of the wires you'll be connecting, exposing enough bare wire to be securely twisted together. Secondly, hold the wires together with the stripped ends aligned, and twist them clockwise. Thirdly, push the wire nut over the twisted wires and twist it clockwise until it's snug. A properly installed wire nut should grip the wires tightly and provide a secure, insulated connection. It's important to note that wire nuts are designed for use with copper wires. If you need to connect aluminum wires, you'll need to use special connectors that are specifically designed for aluminum to copper connections. These connectors are filled with an antioxidant compound that prevents corrosion and ensures a reliable connection between the dissimilar metals. When working with electrical wiring, always follow safety precautions. Firstly, turn off the power to the circuit you'll be working on at the breaker box. Secondly, use a voltage tester to confirm that the power is off before you begin working. Thirdly, wear appropriate safety gear, such as insulated gloves and eye protection. By following these guidelines, you can ensure that your electrical connections are safe, reliable, and compliant with electrical codes. Remember, if you're unsure about any aspect of electrical wiring, it's always best to consult a qualified electrician. Wire connectors, including wire nuts, are designed to create a secure and insulated connection between two or more electrical wires. The primary function of a wire connector is to provide a mechanically strong and electrically conductive joint while also preventing accidental contact with live wires. Wire connectors are commonly used in residential, commercial, and industrial electrical systems. There are several types of wire connectors available, each designed for specific applications and wire sizes. Wire nuts, also known as twist-on wire connectors, are one of the most common types of wire connectors. They consist of a plastic or thermoplastic outer shell with a tapered metal insert. The metal insert is threaded to grip the wires as the wire nut is twisted on. Wire nuts are available in various sizes and colors to accommodate different wire gauges and the number of wires being connected. Push-in wire connectors, also known as push-in terminals, are another type of wire connector that offers a quick and easy way to connect wires. These connectors have spring-loaded contacts that securely grip the wires when they are inserted into the connector. Push-in wire connectors are commonly used in lighting fixtures, outlets, and switches. Screw-on wire connectors, also known as terminal blocks, provide a secure and reliable connection by using screws to tighten the wires against a metal plate. Screw-on wire connectors are often used in control panels, distribution boards, and other applications where a high level of reliability is required. Insulation displacement connectors or IDC are designed to create a connection by piercing the insulation of the wires and making contact with the conductors. IDC are commonly used in low-voltage applications, such as telephone and data cables. When selecting a wire connector, it's important to consider the wire gauge, the number of wires being connected, the voltage and current rating, and the environmental conditions. The wire connector should be rated for the specific wire gauge and number of wires being used to ensure a secure and reliable connection. The voltage and current rating of the wire connector should be equal to or greater than the circuit's voltage and current to prevent overheating and electrical hazards. The environmental conditions, such as temperature, humidity, and exposure to chemicals, should also be considered when selecting a wire connector. Some wire connectors are designed for use in harsh environments and are resistant to corrosion, moisture, and chemicals. Proper installation of wire connectors is essential for a safe and reliable electrical connection. Always follow the manufacturer's instructions for preparing the wires, inserting them into the connector, and tightening the connector. Over-tightening or under-tightening the connector can lead to loose connections, overheating, and electrical hazards. Before working on any electrical system, always turn off the power at the breaker box and verify that the power is off using a voltage tester. This will help prevent electrical shock and other injuries. When making electrical connections, always use approved wire connectors that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Listed wire connectors have been tested and certified to meet safety standards and performance requirements. Periodically inspect wire connections for signs of damage, corrosion, or loose connections. If any problems are found, replace the wire connector immediately. Loose connections can cause overheating, arcing, and electrical fires. When replacing wire connectors, always use the same type and size of connector that was originally installed. Using a different type or size of connector can lead to compatibility issues and electrical hazards. Wire nuts, also known as twist-on connectors, are a type of electrical connector used to join two or more wires together. They are commonly used in residential, commercial, and industrial electrical wiring. Wire nuts consist of a plastic or thermoplastic outer shell and a conically shaped metal spring insert. The wires are inserted into the wire nut, and the wire nut is twisted, causing the metal spring to grip the wires and create a secure connection. Wire nuts are color-coded to indicate the range of wire sizes they can accommodate. The color of the wire nut corresponds to the minimum and maximum wire gauges that the wire nut can be used with. It's important to use the correct size wire nut for the wires being connected to ensure a secure and reliable connection. To install a wire nut, firstly, strip the insulation from the ends of the wires to be connected. Secondly, hold the wires together with the stripped ends aligned. Thirdly, twist the wires together clockwise. Fourthly, push the wire nut over the twisted wires and twist it clockwise until it's snug. The wire nut should grip the wires tightly and provide a secure insulated connection. Wire nuts are designed for use with copper wires. If you need to connect aluminum wires, you'll need to use special connectors that are specifically designed for aluminum to copper connections. These connectors are filled with an antioxidant compound that prevents corrosion and ensures a reliable connection between the dissimilar metals. When working with electrical wiring, always follow safety precautions. Firstly, turn off the power to the circuit you'll be working on at the breaker box. Secondly, use a voltage tester to confirm that the power is off before you begin working. Thirdly, wear appropriate safety gear, such as insulated gloves and eye protection. Wire nuts are an essential component of electrical wiring systems, providing a safe and reliable way to connect wires. By following proper installation techniques and safety precautions, you can ensure that your electrical connections are secure and compliant with electrical codes. When selecting wire nuts, choose ones that are listed by a recognized testing laboratory such as UL. Listed wire nuts have been tested and certified to meet safety standards and performance requirements. Regularly inspect wire connections for signs of damage, corrosion, or loose connections. If any problems are found, replace the wire nut immediately. Loose connections can cause overheating, arcing, and electrical fires. Electrical codes and standards are in place to ensure the safety of electrical installations and protect people and property from electrical hazards. These codes and standards are developed and maintained by organizations such as the National Fire Protection Association or NFPA, the Institute of Electrical and Electronics Engineers or IEE, and Underwriters Laboratories or UL. The National Electrical Code or NEC, published by the NFPA, is the most widely adopted electrical code in the United States. The NEC provides comprehensive requirements for electrical wiring, equipment, and installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and best practices. Electrical codes and standards are not laws, but they are often adopted by state and local governments as mandatory requirements. In addition, insurance companies and other organizations may require compliance with electrical codes and standards as a condition of coverage or membership. The electrical inspections are conducted to verify that electrical installations comply with applicable codes and standards. Electrical inspectors are typically employed by local governments or independent inspection agencies. They review electrical plans, inspect electrical installations, and issue permits or approvals. Failure to comply with electrical codes and standards can result in fines, penalties, and even criminal charges. In addition, non-compliant electrical installations can pose a significant safety risk and increase the likelihood of electrical fires, shocks, and other hazards. It's important to note that electrical codes and standards are constantly evolving to keep pace with technological advancements and emerging safety concerns. Therefore, it's essential to stay up to date on the latest requirements and best practices. One way to stay informed is to attend electrical code training courses and seminars. These courses can provide valuable insights into the latest code changes and help you understand how to apply them in real-world situations. Another way to stay informed is to subscribe to electrical industry publications and online resources. These publications often feature articles and updates on electrical codes and standards, as well as other important industry news. When working with electrical systems, it's always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to ensure that electrical installations are safe, compliant, and reliable. They can also help you navigate the complexities of electrical codes and standards and ensure that your electrical work meets all applicable requirements. Grounding is a critical aspect of electrical safety that helps protect people and property from electrical hazards. Grounding provides a low-resistance path for fault current to flow back to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment, such as enclosures, raceways, and appliances, to the grounding electrode system. This helps to prevent electric shock by providing a path for fault current to flow back to the source, causing the overcurrent protection device to trip. System grounding connects the neutral conductor of an electrical system to the grounding electrode system. This helps to stabilize the voltage of the system and reduce the risk of voltage surges. The grounding electrode system consists of one or more grounding electrodes that are buried in the earth. Common types of grounding electrodes include ground rods, ground plates, and underground metal water pipes. The grounding electrode system must be properly sized and installed to ensure that it can effectively carry fault current back to the source. The size of the grounding electrode conductor, which connects the grounding electrode system to the electrical system, is determined by the size of the service entrance conductors. The grounding electrode conductor must be large enough to carry the maximum fault current that could flow through the system. Grounding is not only a safety requirement, but it also helps to improve the performance of electrical equipment. Properly grounded equipment is less likely to experience voltage fluctuations and other electrical disturbances that can damage equipment and reduce its lifespan. There are several common grounding mistakes that can compromise the safety and performance of electrical systems. One common mistake is failing to properly bond metal parts of electrical equipment. Bonding ensures that all metal parts are electrically connected, providing a low resistance path for fault current to flow back to the source. Another common mistake is using undersized grounding conductors. Grounding conductors must be sized according to the electrical code to ensure that they can effectively carry fault current. A third common mistake is failing to properly maintain the grounding system. Grounding electrodes and conductors should be inspected periodically for signs of damage or corrosion. If any problems are found, they should be repaired or replaced immediately. When working with electrical systems, it's always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to ensure that electrical installations are safe, compliant, and reliable. They can also help you design and install a proper grounding system that meets all applicable code requirements. Overcurrent protection is an essential safety feature in electrical systems that protects against excessive current flow, which can cause overheating, damage to equipment, and even electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. Circuit breakers are electromechanical devices that automatically trip and interrupt the flow of current when an overcurrent condition occurs. They can be reset manually after the fault has been cleared. Fuses are overcurrent protection devices that contain a fusible link that melts and breaks the circuit when an overcurrent condition occurs. Fuses must be replaced after they have blown. There are two main types of overcurrent conditions: overload and short circuit. An overload occurs when the current flowing through a circuit exceeds the circuit's rated capacity. Overloads can be caused by excessive loads on the circuit, such as too many appliances plugged into a single outlet. A short circuit occurs when there is a direct, low-resistance connection between two conductors of opposite polarity. Short circuits can be caused by damaged insulation, loose connections, or accidental contact between conductors. Overcurrent protection devices are rated in amps, which indicates the amount of current that the device can carry before it trips or blows. The amp rating of an overcurrent protection device should be matched to the ampacity of the circuit conductors. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. Overcurrent protection devices must be installed in readily accessible locations so that they can be easily reset or replaced. They should also be properly labeled to indicate the circuits they protect. When selecting overcurrent protection devices, it's important to consider the type of load being protected. Different types of loads, such as motors and transformers, have different overcurrent characteristics. The overcurrent protection device should be selected to protect the load without causing nuisance tripping. Overcurrent protection devices should be tested periodically to ensure that they are functioning properly. Circuit breakers can be tested using a circuit breaker tester, and fuses can be tested using a continuity tester. If an overcurrent protection device fails to trip or blow when it should be replaced immediately. Overcurrent protection is a critical aspect of electrical safety that helps to protect people and property from electrical hazards. By properly selecting, installing, and maintaining overcurrent protection devices, you can help to ensure the safety and reliability of your electrical system. Wiring methods refer to the different ways in which electrical conductors are installed and protected in buildings and other structures. The choice of wiring method depends on several factors, including the type of building, the environment, and the electrical code requirements. There are several common types of wiring methods, including non-metallic sheath cable or NM cable, also known as Romex, is a type of electrical cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. NM cable is commonly used for residential wiring and is typically installed in walls, ceilings, and floors. Metallic conduit is a type of rigid metal tubing that is used to protect electrical conductors. Metallic conduit provides excellent protection against physical damage and is often used in commercial and industrial applications. Electrical metallic tubing, or EMT, is a type of thin-walled metallic conduit that is easier to bend and install than rigid metallic conduit. EMT is commonly used in commercial and industrial applications where a high degree of protection is not required. Flexible metal conduit is a type of flexible metallic tubing that is used to protect electrical conductors in areas where flexibility is required. Flexible metal conduit is often used to connect motors and other equipment that vibrate or move. Armored cable, or AC cable, also known as BX cable, is a type of electrical cable that consists of insulated conductors wrapped in the flexible metal armor. AC cable provides good protection against physical damage and is often used in older homes and buildings. When selecting a wiring method, it's important to consider the environment in which the wiring will be installed. For example, wiring that is installed in damp or wet locations must be suitable for wet locations. Wiring that is installed in hazardous locations, such as areas where flammable materials are present, must be explosion-proof. It's also important to consider the electrical code requirements when selecting a wiring method. The electrical code specifies the types of wiring methods that are permitted in different types of buildings and locations. Proper installation of wiring methods is essential for electrical safety. Wiring should be installed in accordance with the electrical code and the manufacturer's instructions. Wiring should be supported properly and protected from physical damage. Connections should be made using approved connectors and methods. When working with electrical wiring, it's always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to ensure that electrical installations are safe, compliant, and reliable. They can also help you select the appropriate wiring method for your specific application and ensure that it is installed properly. Wire gauge refers to the size or diameter of an electrical wire. The gauge of a wire is measured using the American wire gauge or AWG system. In the AWG system, smaller numbers indicate larger wires, and larger numbers indicate smaller wires. For example, a 12 American wire gauge wire is larger than a 14 American wire gauge wire. The gauge of a wire is an important factor to consider when selecting wires for electrical wiring. The gauge of the wire determines the amount of current that the wire can safely carry. The ampacity of a wire is the maximum amount of current that the wire can safely carry without overheating. The ampacity of a wire depends on the gauge of the wire, the type of insulation, and the ambient temperature. The National Electrical Code, in Table 310.15, V16, specifies the ampacities of different types of wires. When selecting wires for electrical wiring, it's important to choose wires that are large enough to carry the expected current load. If the wires are too small, they can overheat and cause a fire. It's also important to consider the voltage drop in the wires. Voltage drop is the decrease in voltage that occurs as current flows through a wire. Excessive voltage drop can cause equipment to malfunction or fail. The amount of voltage drop in a wire depends on the length of the wire, the current flowing through the wire, and the gauge of the wire. Larger wires have less voltage drop than smaller wires. When selecting wires for electrical wiring, it's important to choose wires that are sized to minimize voltage drop. There are several types of wire insulation available, including thermoplastic high heat resistant nylon coated or THHN, thermoplastic heat resistant water resistant or THW, and cross-linked polyethylene or XLPE. The type of insulation affects the ampacity of the wire and its resistance to heat, moisture, and chemicals. When selecting wires for electrical wiring, it's important to choose wires with insulation that is suitable for the environment in which the wiring will be installed. For example, wires that are installed in damp or wet locations must have moisture-resistant insulation. When working with electrical wiring, it's always best to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to ensure that electrical installations are safe, compliant, and reliable. They can also help you select the appropriate wire gauge and insulation for your specific application.